We were in a position recently where we wanted to accumulate all the evidence we could for a peptide or mimetic being either helical or not in solution. We did 2D NMR, we looked for cross-peaks, we did CH, chemical exchange, we did CD. But in addition to that, there's a very easy test. Chemical shift indices, CSIs, plotting the C-alpha protons relative to 4.0. Any upfield shifts to less than 4.0 are indicative of helicity. Any downfield shifts are indicative of a more beta sheet extended conformation. We did a Ramachandran plot based on our calculations. 2 residues were outside the helical motif, but the rest should be nicely helical. And when we plotted the CSIs, they were all negative, indicative of helicity. Typically, the least negative in the series are leucines, and that's exactly what we see. They're still negative, but less so than others. So that was our first peptide mimetic. We wanted to compare that with another one, which we suspected was more helical, more constrained. So we did the same experiment. We plotted both the CSIs, blue for the first one, and red for the putatively more constrained one. And you see in the more constrained case, chemical shifts for the CH alphas are more negative, indicative of more helicity. It's a very simple test. And nicely, for our particular peptide mimetics, we could explain why 2 of the residues give a very abnormal chemical shift. They're the ones actually outside the helical motif, and they're in the shielding region of a benzene ring. There you have it. Chemical shift index factors, a very easy test for helicity, which complements the others that you might collect. Thank you very much for listening. Bye-bye.